Your Honour, I appear with my learned friend Mr Harker in relation to Your Honour's case study into vehicle design and safety.
Thank you, Mr Castleton.
Your Honour, please, I appear with my learned friend Miss Woodland for the state entities.
Thank you, Mr Free.
I think that concludes appearances, Your Honour. If I could just take an opportunity to make some brief opening remarks. Today's case study hearing will examine the safety of firefighting vehicles used by the New South Wales Rural Fire Service and Fire and Rescue New South Wales. Your Honour's case study hearing arises in part out of the tragic loss of the lives of 3 firefighters during the 2019-2020 bushfire season. Jeffrey Keaton and Andrew O'Dwyer died responding to the Greenwattle Creek fireground on 19 December 2019 after the RFS truck they were travelling in was struck by a burning tree at Wilson Drive, Buxton. Their colleagues, Carlos Quinteros, Benjamin Fraser and Timothy Penning, were seriously injured. On 30 December 2019, Samuel McPaul died responding to the Green Valley Fire, Taumamo. His RFS truck was lifted from the ground by fire-generated vortices and dropped on its roof. Andrew Goody and Rodney O'Keefe were seriously injured in that incident. Your Honour, 2 further firefighters, Darryl Aldridge and Irene Patros from Fire and Rescue New South Wales, sustained serious injuries in a separate incident on 10 November 2019. A tree fell onto their appliance whilst they were responding to the Kearn Road South Arm fire. In each of the 3 incidents, Your Honour, considered in the 2020 New South Wales bushfire inquiry. That inquiry recommended relevantly the following. Firstly, recommendation 40A, that all light tankers across New South Wales fire authorities be fitted with a single point crew protection safety spray system and radiant heat protection. Recommendation 40B, that all medium and heavy tankers across New South Wales fire authorities be fitted with radiant heat protection blankets, wheel and halo spray systems. And importantly, Your Honour, recommendation 40C, that additional research be undertaken to determine the most appropriate cabin protection for different frontline vehicles. In response to the first 2 recommendations, that is recommendation 40A and 40B, the New South Wales Government in June of last year allocated a further $105.6 million to the RFS to deliver new trucks and retrofit old trucks. This builds on the $67.9 million allocated since the 2019-2020 bushfire season to the RFS, Fire and Rescue New South Wales, National Parks and Wildlife Service and the Forestry Corporation. 71 compliant light tankers, or Category 9, appliances have been built and handed over to the RFS brigades, and the manufacture of 30 new Category 9 appliances has commenced, which will replace the remainder of the light tankers identified as requiring improved firefighting safety. And then finally, Your Honour, 62 existing heavy tankers have been retrofitted, and the RFS continues to build new Category 1 and Category 7 appliances to replace the heavy and medium tankers identified as requiring improved safety mechanisms. Relevantly, in respect of the 3rd recommendation, 40C, namely cabin protection, the RFS, in partnership with the Monash University Accident Research Centre, or MUARC, have collaborated to determine the appropriateness and feasibility of further developing the new and existing fleet to provide greater cabin protection, including through falling object protective structures, or FOPS. Additionally, the RFS will be seeking industry engagement to look for new generation fire tankers. As at 24 March of this year, the RFS firefighting appliances, namely Category 1 appliances, through to Category 11 appliances, comprise of 4,017 appliances in total. Further, 173 appliances are in build, with an additional 22 appliance orders to be placed by April of this year. Your Honour, I anticipate that RFS Deputy Commissioner Stewart may speak to this in more detail later today. The management of those firefighting assets was recently the subject of a report by the New South Wales Auditor-General. The Auditor-General's focus was not on the improvement of vehicles to protect firefighters, but instead on how effectively the RFS plans and manages its equipment, particularly its vehicle fleet, to prevent, mitigate and suppress bushfires. The Auditor-General, however, observed that the average age of the RFS vehicle fleet has been reduced from 21 years in 2017 to 16 years in 2022. This reflects a considerable investment in new vehicles by the RFS to renew some of its fleet. On 17 March this year, some of those assisting Your Honour, including Professor Gibietta, an independent court-appointed expert, myself and my instructing solicitor, had the opportunity to inspect vehicles from the fleet at the RFS Greater Sydney Area Command in Glendenning. The inspection was led by RFS Deputy Commissioner Carl Stewart and RFS Engineer Cameron McEwen. Andrew Simons, Fleet Project Officer at Fire and Rescue New South Wales, was also in attendance. Representative members of the MUARC team were also present, including Dr Muir, Lead Researcher and Senior Researchers Dr Richardson and Associate Professor David Logan. Your Honour, this was an incredibly useful exercise in the context of appreciating the challenges currently faced by the RFS and the MUARC team in responding with the best of intentions to Recommendation 40C of the New South Wales Bushfire Inquiry. We're also grateful for the opportunity to inspect the relevant RFS frontline vehicles. Over the course of today, Your Honour will hear evidence going to 5 issues. Those issues are as follows. First, whether RFS and Fire and Rescue New South Wales fire appliance design during the 2019-2020 bushfire season complied, and whether it now complies with relevant standards and requirements for truck occupant cabins to protect the driver and passengers from rollover, crash impact and any tree fall incident, including crashworthiness, strength or energy dissipation requirements, and active safety systems such as seatbelts, airbags, padding window with safety glazing and emergency braking systems. Whether the fire appliance designs were then and are now fit for their intended purpose and otherwise adequate. In respect of each of the incidents involving Jeffrey Keaton, Andrew O'Dwyer, Samuel McPaul and Darryl Aldridge and Irene Patchos, whether, as appropriate, the particular appliance was fit for purpose in terms of cabin protection during a vehicle rollover, cabin protection if objects are falling on the roof of the cabin, and active safety systems. A falling object protective structure, FOPS, operator protective structure, OPS, or rollover protection structure, ROPS, is suitable and or achievable for use in fire appliances. Whether Recommendation 40C of the New South Wales Bushfire Inquiry with respect to vehicle design and safety is sufficient, and the adequacy of steps taken by New South Wales Rural Fire Service in response to this recommendation. And then finally, Your Honour, whether it is otherwise necessary or desirable for Your Honour to make recommendations pursuant to Section 82 of the Coroners Act in relation to any matter connected with these fire inquiries. Coming, if I may, Your Honour, to the 3 particular incidents. Before turning to each of the three incidents, can I take this opportunity to acknowledge that revisiting those tragic circumstances may be immensely painful for the families, friends, colleagues and communities of Samuel, Jeffrey and Andrew. I also acknowledge today that there may be friends, family and colleagues who may be watching these proceedings. Your Honour, I also acknowledge those who were injured during the relevant incidents, namely Carlos Quinteros, Benjamin Fraser, Timothy Penning, Andrew Goody, Rodney O'Keefe, Darryl Aldridge and Irene Patchos. And of course, Your Honour, those who responded to each of the three incidents. Coming now to the Kearn Road fire incident. At about 3:14 p.m. on 10 November 2019 at Coulters Road, North Congreani, I think it's pronounced, tanker 397S had parked at a fire ground to clear a fallen tree. The tanker was a Fire and Rescue New South Wales Isuzu FTS 700 4x4 locker, which provided seating for a crew of 6. It is believed to have been manufactured before 2000 and possibly around 1994. It had a gross vehicle mass, or GVM, of about 12.5 tonnes. In the left rear passenger seat was Irene Patchos. Darryl Aldridge was in the right rear passenger seat, with Luke Babula and Leslie McQueen occupying the 2 front seats of the vehicle. As Irene began to alight from the truck's cabin, a tree of approximately 60 metres in height and with a diameter of 1 metre snapped at its trunk, fell and landed across the rear of the passenger cabin. Irene was knocked to the ground. Darryl, in the right rear passenger seat, was struck by the collapsing roof of the cabin and pushed up against the bench seating. Both sustained severe injuries. I pause to inform Your Honour that an image will shortly be shown of the impacted vehicle to allow any party or person watching these proceedings sufficient time should they not wish to see this evidence. The impacted vehicle is shown in this image now, Your Honour. Coming, if I may, Your Honour, to the Green Wattle Creek incident. Shortly before 11:30 p.m. on 19 December 2019, Jeffrey Keaton was driving fire appliance Horsley Park 1 Alpha along Wilson Drive, Buxton, in response to the Green Wattle Creek fire. Andrew O'Dwyer was in the front passenger seat. 3 of their crewmates were seated in the rear of the vehicle: Carlos Quinteros, Benjamin Fraser and Timothy Penning. Horsley Park 1 Alpha was an RFS Isuzu chassis dual cab, Category 1 heavy tanker appliance with a gross vehicle mass of 13.7 tonnes. Whilst the truck was travelling at about 70 kilometres per hour, a large burning iron bark gum tree of approximately 30 metres in height broke away from its burning base and impacted the top of the vehicle's roof and windscreen section. The force of the impact and damage to the vehicle likely caused Jeffrey to immediately lose consciousness and as such lose control of the vehicle. Horsley Park 1 Alpha continued travelling forward from the southbound lane into the northbound lane, dragging a tree branch which had broken away from the main section of the tree. At a location approximately 60 metres from the initial collision, the appliance left the northbound lane and continued travelling up and along a dirt and vegetated embankment. After travelling a further 32 metres, Horsley Park 1 Alpha started to rotate in a clockwise direction. It rolled 270 degrees before coming to rest on the offside of the vehicle. The cabin was compressed significantly rearwards past the steering wheel. Again, Your Honour, I pause to inform Your Honour that an image will shortly be shown of the impacted vehicle to allow any party or person watching these proceedings sufficient warning should they not wish to see this particular evidence. Your Honour, tragically, Jeffrey and Andrew died from their injuries, and Carlos, Benjamin and Timothy sustained serious injuries in that incident. Coming now to the Green Valley fire incident. Late in the afternoon on 30 December 2019, at a property known as Lightwood in Jingellic, the crew of appliance Culkin 2 Alpha were responding to the Green Valley fire. Culkin 2 Alpha was an RFS Isuzu Motors FSS 500 Category 2 crew cab manufactured in 1999. That afternoon, the vehicle was reportedly fully laden with 800 litres of water with a mass of 1.8 tonnes. The gross vehicle mass of the vehicle was estimated at somewhere between 11.8 and 15 tonnes. Just after 5 p.m, the vehicle is believed to have been lifted at the rear by a fire-generated vortex. It was inverted and dropped on its roof, resulting in significant cabin roof crush. Again, Your Honour, I paused to inform Your Honour that an image will shortly be shown of this particular vehicle to allow any party or person watching Your Honour's proceedings sufficient time should they not wish to see this particular evidence. At the time, Your Honour, Andrew Goody was driving the vehicle. Samuel McPaul and Rodney O'Keefe were in the rear of the vehicle in an area known as the crew refuge area. That area is an open area within the rear tray of the tanker. As Your Honour knows, tragically Samuel died as a result of his injuries. Andrew and Rodney sustained serious injuries also. Coming now, Your Honour, to the expert evidence on the adequacy of the relevant vehicles. This morning, Your Honour, we'll hear evidence from Professor Rafael Gibieta, who is a professor at the University of New South Wales in its Transport and Road Safety Research Group. On the basis of what is set out in his reports, it is anticipated that Professor Gibieta will give evidence to the effect that none of the three vehicles were fit for purpose in terms of cabin protection during a vehicle rollover. The crew cabin of the Green Valley appliance was not compliant with relevant European Union or EU standards. To provide fit-for-purpose rollover protection, the cabins need to be reinforced to sustain relevant loads and energy. Also, the crew refuge area could be redesigned. In relation to the Kearn Road appliance, Professor Gibieta expresses the opinion that it was compliant with some EU standards, but it would not have been fit for purpose in terms of occupant protection during a rollover, where the vehicle rolls at least 180 degrees and if it had been subject to a rollover greater than 180 degrees lateral rotation, the cabin would have deformed in a manner similar to the Green Valley appliance. While the Green Wattle Creek appliance was compliant with some EU standards, similarly, if it had been subject to a rollover greater than 180 degrees, the driver's section of the truck cabin would likely crush in a similar way as the roof was deformed in the Kearn Road fire incident. This particular appliance had a roll bar installed just behind the crew cabin rear passenger section. The roll bar would not provide fit-for-purpose protection for the front seat occupants against roof crush if the vehicle pitches forward during a rollover event. Your Honour will hear that the reason Professor Gibietta refers to EU standards is that the Australian standards are generally non-existent in respect of relevant roof crush standards and standards for FOPs and ROPs. It is also expected that Professor Gibietta will give evidence that none of the three appliances were fit for purpose in terms of cabin protection from objects falling on the cabin roof. The three appliances were not strengthened to withstand any falling objects, nor would have been compliant with tests such as those required by standards for earth-moving equipment and tractors. Engineering technology exists to manufacture lightweight, high-strength falling object protection systems and rollover protection systems, or alternatively strengthen the cabin structure that does not compromise a fire appliance vehicle's ability to stop or require reducing the weight of both water and firefighting equipment on board vehicles. The crew compartments of the fire appliance must be strengthened and active safety systems such as Advanced Emergency Braking System, AEBS, be implemented to protect crews. The European regulations may even be insufficient, as would have likely been the case in the Green Wattle Creek incident, and more robust designs that don't compromise payload and braking efficiency would need to be explored and rigorously tested. Ultimately, whilst significant positive work has occurred through the MUARC team in collaboration with the New South Wales Rural Fire Service, it is anticipated that Professor Gibietta will give evidence that there is still more work that needs to be done. Coming, if I may, to MUARC. Your Honour will also hear evidence from Dr. Shane Richardson and Associate Professor David Logan of the Monash University Accident Research Centre. Both have been involved in the preparation of two reports dated March of this year relating to the Centre's recent work with the RFS. In that work, the MUARC team have identified numerous challenges to improving cabin protection through adding FOPs to vehicles. Some of those challenges include the number of different apparatus categories and the range of vehicle variants, makes and builders within each category. Vehicle mass, as typically RFS vehicles already operate close to the rated gross vehicle mass of the base chassis. This may leave little to no scope to incorporate a FOPS without necessitating a significant redesign of other systems to either reduce weight or compromise water payload capacity. The ability of a solution to complement existing tanker protection mechanisms whilst retaining a safe and operable space for firefighters. The existing FOPS designs serve as a protection mechanism for heavy plant, and the challenges of adapting this to a standard heavy vehicle with a forecast 25-year service life, whilst retaining Australian design rules and workplace health and safety compliance. Given these challenges, the MUARC team assert that it is important to consider the safety system in which RFS vehicles operate as a whole. Current road safety management, Your Honour, in Australia is guided by the premise of a safe system, capturing not only driver behaviour but vehicle design, and also the roles of vehicles and roads and the way in which these are managed and coordinated. You know, I just have displayed now a diagram taken from the MUARC technical report which shows what a safe system approach to road safety ought to be. Your Honour, it is anticipated that Dr. Richardson and Associate Professor Logan will give evidence that engineering solutions cannot be isolated from the rest of the safe system. In some circumstances, vehicle design solutions can increase the risk to drivers by promoting complacency or overconfidence or creating new hazards. For example, many existing solutions are not designed for older vehicles, making retrofitting difficult and can add significant weight to emergency vehicles which, by design, are already approaching their gross vehicle mass. Interactions with other safety features also need to be considered, including those specific to fire vehicles such as burnover protection, that is heat reflecting curtains and external water sprays. The MUARC team have undertaken a three-stage approach to date. Stage 1 has included a scientific literature review to identify what factors are associated with emergency vehicle safety. Your Honour, Stage 2 has comprised a data linkage and risk analysis, document analysis, site visits of vehicles and fleet practices, an online survey being sent to employees and volunteers at RFS, and a range of focus groups designed to establish the nature and extent of the problem. Stage 3 has included a vehicle engineering review consisting of a series of site visits to review a range of vehicle types and cabin structures, document analysis to map key documentation related to cabin protection systems and New South Wales RFS fleet structure, and a review of standards to evaluate the suitability of current truck roof strength standards, including UNE, ECE, R29, ISO 3449, in providing adequate protection for the rollover and falling object incidents. It is anticipated that members of the MUARC team will give evidence of their work on each of these stages. In respect of next steps, in summary, the MUARC team have recommended that the RFS firstly develop a data conceptual framework for vehicle safety, secondly undertake a review of the framework underpinning driver training and safety to capture requirements for entry, training, licensing, re-entry where necessary, and consider a wide range of options to support driver training at the RFS. Thirdly, undertake a review of their fleet management practices and consider developing a high-level strategy. There will be likely compromises involved both in sourcing vehicles with enhanced primary safety features such as electronic stability control, ESC, rollover stability control, RSC, and in implementing one or more FOPS or ROPS solutions. Consequently, it may become necessary to consider better matching of vehicle deployment with the primary environment in which they will serve. And fourthly, Your Honour, establish a fit-for-purpose set of rollover, falling object test criteria and assess potential engineering solutions in an experimental setting. In respect of the last recommendation, the MUARC team have identified potential engineering solutions to improve cabin performance for rollover and falling objects. First, in-vehicle devices, particularly the redesign of the rear seats as a cost-effective solution to improve seatbelt use and overall safety. Bench seats could be replaced with moulded seats. Secondly, to better optimise for ROPS and FOPS, changes to the vehicle headboard, including extending it out as high and wide as practicable, and/or modification of the shape of the headboard to optimise load transfer to the truck chassis rails during rollover or falling object loading. And thirdly, Your Honour, improving structural performance of RFS trucks in rollover and potentially in falling object impacts by using an intermediate solution involving foam filling the void between the internal and external surfaces of the existing roof, A, B and C pillars in the cabin and the cabin rear wall. Testing would need to be undertaken to determine the level of protection this solution might offer. In the longer term, the MUARC team recommends that consideration be given to addressing the rollover propensity of heavy-duty firefighting vehicles due to the inherently high centre of mass resulting from existing designs. This would necessitate a complete redesign of the vehicles, but in addition to reducing crash risk, could also target the range of ergonomic and safety issues relating to cabin and equipment access that result in the majority of current injuries. Your Honour will hear evidence shortly from Professor Gibietta, Dr. Richardson and Associate Professor Logan about the adequacy of these solutions. Like the New South Wales Rural Fire Service, Fire and Rescue New South Wales are monitoring the outcome of the work by the Monash University Accident Research Centre. It is expected that Your Honour will receive evidence that following the results of the MUARC study, the Australasian Fire and Emergency Service Authorities Council, of which Fire and Rescue New South Wales is a member, intends to develop guidelines on ROPS and FOPS for tankers. This may go some way, Your Honour, to filling some of the gap left by the absence of any applicable Australian standard. Your Honour, before I call the expert witnesses, for completeness, I note that non-publication orders have previously been made by Your Honour in respect of any evidence relating to the personal addresses, personal email addresses, personal phone numbers and/or medical records, other than autopsy reports, of any person who are the subject of evidence. For current purposes, orders were made in these terms as follows. On 3 February last year, with respect to the Greenwattle Creek fire and the deaths of Jeffrey Keaton and Andrew O'Dwyer. On 6 September 2021, with respect to the Green Valley fire and the death of Samuel McPaul. And on 14 December last year, with respect to the Stage 2 case study into vehicle design and safety. Your Honour, that concludes my opening remarks. If it's appropriate, Your Honour, I'll now seek to call the 3 experts, if I may, who will give their evidence concurrently.
Thank you.
Could I firstly call Professor Raphael Gibietta, and then I'll move to Dr. Richardson and then Associate Professor Logan.
Silence, please. Do you solemnly and sincerely declare and affirm that the evidence you shall give be the truth, the whole truth, and nothing but the truth? If so, please say, I do.
I do.
Have a seat, please.
Thank you.
Professor, would you please state your full name, present occupation and your professional address?
Raphael Hilary Gibetta. I'm a emeritus professor from the University of New South Wales and associated with the Transport and Road Safety Research Unit. I'm also an adjunct professor with the Department of Forensic Medicine at Monash University, which is located at the Victorian Institute of Forensic Medicine in the Coroners Court there.
Thank you. You're right. I now call Dr. Shane Richardson, who will be joining remotely.
Dr. Richardson, can you see and hear us?
Yes, I can. No, I can't see you.
Ah, you
No.
can see me.
Yes.
Thank you. You'll just hear from the court officer now.
Dr. Richardson, I'm going to swear you in. Silence, please. Do you swear by Almighty God that the evidence you shall give will be the truth, the whole truth, and nothing but the truth? If so, please say I do.
I do.
Dr. Richardson, can you see and hear me clearly?
Yes, I can.
Would you please state your full name, present occupation and current professional address?
Shane Andrew Richardson. I call myself a forensic engineer. I'm a director of Delta V Experts, forensic engineering consultancy, 9 Springbank Street, Tullamarine, 3043.
Thank you, Dr. Richardson. Your Honour, I have now brought into the virtual courtroom Associate Professor David Logan to be sworn.
Associate Professor Logan, can you see and hear us?
Good morning.
Good morning. You'll just hear from the court officer now.
Silence, please. Do you solemnly and sincerely declare and affirm that the evidence you shall give will be the truth, the whole truth, and nothing but the truth? If so, please say I do.
I do.
Associate Professor, can you see and hear me clearly?
I can, yes.
Would you please state your full name, present occupation and your current professional address?
I'm Associate Professor David Logan. My occupation is a researcher, senior researcher at the Monash University Accident Research Centre of 21 Alliance Lane, Monash University, Victoria.
Thank you, Associate Professor Logan. I'll just return now, if I may, to Professor Gibetta. Professor, do you have with you this morning the 2 reports you've prepared in relation to the matters presently before Her Honour?
Yes, I do.
And is your first report a report dated the 14th of December 2022?
Yes, it is.
Do you adhere to the opinions that you've expressed therein today?
Yes, I do.
And have you more recently, quite recently, prepared a further report titled a supplementary report dated the 27th of March 2023?
Yes, I did.
And do you have that with you this morning?
Yes, I do.
And do you adhere to the opinions you've expressed throughout that report today?
Yes, I do.
Now, gentlemen, what I'd firstly like to do is to seek to get some consensus, if I may, on some terminology. And I'll start firstly with you, Professor Gibetta. Could you explain in lay terms what a FOPS or a falling object protection system is?
FOPS is an acronym for a falling object protection system, and what it's meant to do is to protect the occupant compartment where below that particular FOPS where it's placed on a vehicle against any falling object that would potentially crush or deform the occupant compartment.
Dr. Richardson, do you agree with that general explanation of what a FOPS is?
In general, yes, but I qualify it that it's about protecting the occupants of that cabin rather than the cabin itself. It's about protecting occupants within the cabin.
And Professor Associate Logan, do you disagree or agree with what you've just heard by your expert colleagues?
I agree in general with my colleagues, although I would reinforce Shane's point. The point is to protect the occupants, and in doing so, you want to protect the occupant compartment from defamation. So they're both right in a way. I think we agree.
And staying with you for the moment, please, Associate Professor Logan, could you again explain in general terms what a rollover protection system is, a ROPS?
It's to a falling object protection system, except it's designed for when the vehicle rolls over, such as when lifted by a fire vortex or in a road going, when tripped or otherwise turned over on the road. It also prevents defamation of the occupant compartment in order to protect the occupants from serious injury or death.
Dr. Richardson, do you wish to add any additional information to that explanation provided by Associate Professor Logan?
No, I'd agree with that.
And Professor Gibietta, is there any additional information you'd add to the explanation just provided by Associate Professor Logan?
In general, I'd agree, but I would distinguish that sometimes the rollover protection system, it's a system, so it could include internal systems such as air curtains, seatbelt pretensioners, and other devices within the vehicle that would fire during a rollover. So it depends what you mean by system. Now, we can isolate ROPS and define it as simply the structural component, which assists with protecting the occupants within the vehicle. So there is a nuance here that needs to be clarified, I'd suggest.
I wish now to just to turn to some aspects of your first report, Professor Gibietta, and you have that there. The first question I wish to ask you, and I'll hear from your colleagues on this as well. You state in your report that in Australia there are no compliance, crashworthiness, strength or energy dissipation requirements currently for truck occupant cabins to protect the driver and or passengers in the event of any rollover or impact, crash or tree fall incident.
That's correct.
Pausing there, Dr. Richardson, do you agree with that statement by Professor Gibietta?
Oh, yes, I agree. In terms of truck cabins, no, there is no standard.
And Associate Professor Logan, do you also agree?
Yes, definitely.
Professor Gibietta, in your first report you go on to say there are no mandatory Australian design rules, ADRs, or Australian standards that cover this aspect of truck cabin design.
That's correct.
Pausing there, Dr. Richardson, do you agree with that statement?
Yes.
And Associate Professor Logan, do you also agree with that statement?
Yes.
Professor Gibietta goes on to say in his first report there is no mandatory Australian design rules governing the minimum static rollover threshold, SRT, for heavy trucks in Australia. Firstly, Associate Professor Logan, do you agree with that statement?
That's correct, as far as I know.
And Dr. Richardson, do you also agree with that statement?
Yes, I do. Yes, I agree.
Professor Gibietta, is there a design standard or regulation in Europe that may have a bearing in relation to commercial or heavy vehicles in Australia in terms of crash worthiness?
Yes, there are. There is a number of them. There is one for cabin strength. The European Union introduced that some time ago. There is I don't think there's any other standard, though, in regards to internal occupant protection, like firing of air curtains or seatbelt pretensioners in the event of a rollover. But for that is for trucks. There are other industry adopted, they're not standards. You can't call them standards, but the industry has adopted them as one way of strengthening the cabin.
And do I take it that those particular ones you've identified had not been incorporated into the Australian design rules?
No, they haven't.
Dr. Richardson, do you agree with that?
That the European standards haven't been incorporated into the Australian design rules? Yes, I do.
And Associate Professor Logan, do you also agree with that position?
Yes, I agree.
I'll return to that topic later. I wish to now to turn to what Professor Giulietta has said in relation to each of the three incidents and whether or not the particular vehicles were fit for purpose in relation to what they're undertaking at the relevant time. Can I deal firstly with the Green Wattle fire incident, and that's the incident involving Mr. Keaton and Mr. O'Dwyer. In summary, Professor, did you form the view that the cabin protection was fit for purpose for that particular vehicle?
No, it wasn't.
And again, we have your report. In summary form, why not?
Well, firstly, I think the cabin wasn't, well, there is a problem here. I have to clarify my position here in regards to that incident. The speed at which that occurred was 70 kilometres per hour. That's a very high speed. And so the severity of the impact would have been difficult to design against, if not impossible to design against.
And just pausing there,
yeah.
That vehicle was travelling on a public road, a sealed road.
Yes. And so to design against that particular, such an impact, you can design against it, but not through strengthening of the cabin, possibly through reduction of speed, possibly through detection of a falling object, though that would have had to have been specifically designed for such a falling object. And there are other alternatives, and I outlined those in my report. So you can decelerate a vehicle to make it survivable, but you have to introduce other systems. A novel system that was proposed by one of my colleagues, Dr. Retnitzer, is an airbag firing in front of the vehicle. It detects whatever's in front of the vehicle, airbag fires and cushions. But at those sorts of speeds, 70 kilometres per hour is particularly difficult and very complex.
You'll see on the screen now a photograph of the relevant vehicle involved at the incident at Green Wattle Creek. Do I understand correctly that here we have the cabin was crushed backwards or rearwards?
Yes.
As a result of the impact with the
Yes.
fallen tree. Can I ask you this, Professor? Would the European or the United States regulations or guidelines been sufficient to have protected the driver, Mr. Keaton, based on the facts as you understand them?
I don't think so. I think it still would have crushed, and I think I did some computations there in my report to show that the impact energy was just overwhelming.
Do you have do you hold a view as to whether or not an advanced emergency braking system may have mitigated the situation or not?
Having reviewed some further, the responses from New South Wales Rural Fire Authority and reflecting on that, it's quite possible it wouldn't have detected the falling branch. And so it would have had to have been a specialised system that would have applied the brakes. No, probably it wouldn't have mitigated it at that point.
And what about electronic stability control, ESC?
That's not relevant to a frontal impact. It would have been relevant to the rollover. Unsure whether it would have kicked in, whether it would have started when it rolled over 60 metres down the road. But to prevent it, but that would have meant that the vehicle would have continued on down the road. So the issue here is to stop the vehicle.
Before we move on, I'll just ask you, if I may, Dr. Richardson, as part of your brief as a member of the MUARC team, did you look specifically at the incident that occurred at the Greenwater fire or not?
No, I didn't look at it specifically. My only overview of it is what's been provided in the report that we're looking at now. It's I doubt that you could build a structure effectively and put on a vehicle that would have protected a driver in this circumstance. I don't think that fitting any systems would have mitigated. Certainly automatic braking systems, the way in which they're designed, they are not going to look for falling trees or falling objects. That's not how the program logic works. Stability control may have, again, and I use that with an extreme caution, may have helped in terms of a subsequent rollover, but that's a real question mark. This is probably an unsurvivable event in almost all vehicles that are on the road at the moment, just because of the circumstances that were
yes.
Pass.
We may have lost you shortly. Can you hear me clearly, Dr. Richardson?
Yes, I can.
I'll just ask now Associate Professor Logan whether, as part of your research as a result of the MUARC brief, whether you looked closely at the Greenwater Creek incident?
I've seen it in the same context, Dr. Richardson, from Dr. Grigibietta's report, and I share their views, their expert assessment of the crash. In my view, this is a crash that would need to have been prevented before the crash happened by some other measures. It was not I don't believe that it's a survivable crash through design. And I agree with what Dr. Richardson and Dr. Grigibietta say with regards to the effectiveness of automatic emergency braking in preventing the crash too. It's highly unlikely that a system that's designed to avoid false positives, meaning braking for random objects, would be able to effectively avoid a falling tree as well, because it would be designed to be resistant to false activation.
Thank you. Professor Gibietta, do you wish to respond to anything that your colleague has just expressed?
Yes, I agree with them both. However, I'll point out to Your Honour, 3 people did survive the crash. They were in the back, and that gives Your Honour some impression as to what it would take to survive. So it would take crushing that vehicle the way it was crushed, and so that points to the paper that I referred to in my report from Dr. Rechnitzer, where he's got a person standing in front of a train and an airbag fires, train's going at 100 kilometres per hour, and that person survives the impact because the airbag protects that person. So that's what we're trying to do, is reduce the kinetic energy to a manageable level. But I agree with both Dr. Richardson and Associate Professor Logan that to design a structure to withstand that is just not possible without substantial increases in mass and weight.
And that may have the unintended consequence of perhaps increasing rollover propensity.
Absolutely, yes.
Turning, if I may, gentlemen, to the Kearn Road fire incident, and I'll just have displayed on the screen shortly the impacted vehicle. Did you form a view, Professor Gibietta, in relation to whether or not that particular fire appliance was fit for purpose?
No, it wasn't. From the perspective of a falling object, regrettably for the victims, that tree happened to fall right in the middle of the rear section of the truck and over the rear header, Had it fallen on the back of the truck, of course, they wouldn't have been injured. Had it fallen in the middle of the truck, I suspect there would have been considerable deformation as well.
Just picking up...
In the middle of the cabin, sorry, in the occupant cabin, I meant. At the, just to explain, the front pillar is called the A pillar, the one in the middle is called the B pillar, the one at the back where the log is the C pillar. So had it fallen over the B pillar, I suspect it would have crushed the cabin as well.
You've expressed in your report that had a ROPS or FOPS structure been installed, or that the crew cabin been strengthened as proposed by Richardson et al., that the crew cabin, it is likely that Irene and Daryl would likely have not suffered any injuries, or the serious injuries that they did sustain would have been reduced to minor injuries.
Yes.
Firstly, why do you say that, and what sort of ROPS or FOPS structure did you have in mind, having regard to the research provided by Richardson and others?
Oh, it would have been a structure which would have had a sort of a, how do you say, a vertical at the rear with a sort of cantilevered structure over the roof. And so that when the log falls, that whole front then either, it depends how it's designed, but it would effectively apply load to the whole cabin structure, which includes both A pillars, B pillars, C pillars. And so the transfer of load is distributed, and so that peak load is not applied to one particular area, but to a number of pillars. And so not unlike the FOPS in the Victorian vehicle, but for the smaller vehicles, the lower category vehicle.
I'll just have those images brought up, which is contained within your primary report, just so Her Honour has the benefit, and I'll see whether we can magnify those. Are they the systems to which you
Yes, I'm
just
referring to those
articulated?
systems, yes.
Now we may pick this up later when we get to sort of engineering limitations. Do you know when those systems were incorporated into the fleet in Victoria?
I think that was after the Coronial inquest by Coroner Ollie.
Associate Professor Logan, do you wish to add to anything that Professor Gibietta has just said in relation to the Kean Road incident? Or?
No, I agree fundamentally with the points that he makes. And
Thank you.
I'm going to talk about the limitations of an engineering solution later. I can reserve my further comments until then.
Thank you. And Dr. Richardson, do you wish to add anything to what you've heard thus far in relation to the Kean Road incident?
Not in terms of the analysis, probably the point about, and it may be relevant to speak later about it, but it's about fit for purpose and how you make that decision, but that may be something for later. And again, I'm aware of issues with the vehicles that you're now displaying in terms of the FOP structure meets a specific criteria, but as Associate Professor Logan pointed out, there are other engineering issues that are now becoming evident having gone down that path. I would not advocate, articulate or present that is a good solution from a holistic perspective. It addresses one specific problem, but it fails to address a whole range of other issues that go along with it. So I would urge caution as using that as being the solution to a potential problem. It is a solution to a specific problem, but for the vehicles themselves, they have other issues that come along with having gone down that specific path.
There you go. I'll make a note that we'll come back to that. But before we move on, if you assume in relation to the Kean Road incident, Dr. Richardson, that the minimum load was around 20 to 30 tonnes, on the assumption that that's about half the weight of the relevant tree, would, in your opinion, if you haven't looked at it closely, please say so, would that sort of weight bearing down on the Victorian type model we see on the screen be adequate protection or not?
I can't say definitively that it would be adequate. It would provide protection. It most likely would provide a level of protection that's going to prevent deaths. It may not prevent all injuries. It is a system and a methodology that would provide protection probably against that type of event. There are just engineering and vehicle issue limitations with that system approach.
Professor Givietta, do you wish to express a view on the Victorian protective system and whether it could withstand 20 to 30 tonnes, and if it could, whether it would be adequate or inadequate protection in relation to occupants?
Oh, I'd agree with Dr. Richardson, and also on the comments that he made with regards to other more complex systems. In other words, rollover. Rollover is a fairly large issue, rollover propensity, and yeah.
I'll turn now, if I may, gentlemen, to the Green Wattle Creek, and I'll have again brought up onto the screen an image of that relevant appliance. Bear in mind, of course, that the evidence in relation to this incident was that the fire-generated vortex may have been in excess of 300 kilometres per hour, that the truck weighs, the gross vehicle mass of the truck was perhaps somewhere between 11.8 and 15 tonnes. Coming to you, if I may, firstly, Professor Givietta, did you form a view in relation to that model, that particular appliance, whether the cabin was fit for purpose or not in relation to protection for occupants?
No, it wasn't fit for purpose. The deformation of the cabin clearly demonstrates that, and it's collapsed like a frame structure without any bracing.
Yes. Associate Professor Logan, do you wish to add anything to what you've either read in Professor Gibietta's report or what you've just heard now from him?
No, I don't, but simple what he says.
And Dr. Richardson, do you wish to add anything?
Apart from the point of saying that it's, for that circumstance, it's not fit for purpose. So that crash environment, I agree that it's collapsed in the way in which has been described. It's not, the structure has not survived the loading that it's been exposed to.
What I'd like to do now is just move into the MUARC research that's been undertaken by the Monash University. Starting with you, if I may, Dr. Richardson, and if you need to refer to the reports, please do so. But I really want to deal with the engineering review, if I may, and some key challenges were identified by the research team in relation to improving cabin protection through adding FOPs to relevant vehicles. Can I ask you, please, Dr. Richardson, if you could just set out in summary form what those key challenges are?
It's providing a space for the occupants to exist within, to do the primary function that they need to do, and be able to carry that out, and then provide them with the structural systems on the vehicle to give them levels or some levels of protection in the event of either an object falling on the cabin of the vehicle or the truck rolling over, and provide protection in those events. But it's the integration of how they undertake their work, what they're there to primarily do, and probably the other overarching layer that needs to be there is how much, if you're going to add a structural system onto the vehicle, how much mass is it going to be? Because whatever mass you add is the water you're going to have to take off or pay for in some other way, so that can they still do the job that they're trying to do?
Professor Gibietta, do you agree or disagree with what you've just heard in relation to those challenges that may be faced?
Yes, I'd agree with Dr. Richardson on that.
Thank you. Associate Professor Logan, could I ask you to explain the concept of a safe system to road safety? And you may have seen the opening earlier this morning where there was a particular diagram displayed, and if you'd like that to be displayed as you explain that concept, please say so.
Certainly, yes. I'm happy to put that up. I wasn't able to see that this morning.
I'll just have that displayed now. It might take a few minutes.
Yep, that's good. The safe system is a way of ensuring that we look at all of the system operating together and in balance. We can't just look at safe vehicles, for example, in isolation, because as we're already seeing as part of the discussions this morning, is that there's a limit to the amount of protection you can provide, what we call passive safety, which is secondary safety, which is the protection to occupants given that crash has occurred. In addition to that, we should also look at active safety, which is preventing crash occurrence in the first place. No engineering solution is able to cope with all possible situations. So our primary focus should be to prevent crashes. And we prevent that through a number of measures. We can prevent it very close to the crash in terms of features like ESC, electronic stability control, or automatic emergency braking. These are features that prevent a crash at very close to the point of impact. But if we go back further to that, we can look at other measures to prevent crashes or to mitigate occupant injury. And that includes things like wearing seat belts. And then if you go back even further, we can look at things like vehicle design to prevent crashes in the first place. We can look at licensing, ensuring that people are appropriately qualified to drive the vehicles that they're driving. They're appropriately trained to be able to drive in the environments that they're driving in. And also that they travel at safe speeds as well. There's no point having the best crash protection in the world if you run into a crash at too high a speed, which exceeds the engineering limits of the vehicle to prevent you from having that crash. So it's really the fundamentals of the safe system are that we should be looking at all possible elements of the system, including access to the system, the way the system's used, and then finally in preventing crashes from occurring and mitigating the severity when a crash does happen. So it's a multifaceted approach.
Could I say this in summary, that when one is looking at an engineering system or solution, firstly it must be fit for purpose, but importantly it cannot be isolated from the rest of the safe system. Is that a fair summary?
That's correct. It's a very fair summary, yes, it's exactly correct.
Professor Gibietta, do you wish to add anything to that explanation of a safe system?
Yes, for Your Honour's benefit, the person who came up with this was Eric Howard, who was the head of road safety at Vic Roads at that time, and presented it to the Australian Transport Safety Bureau a couple of decades ago. The Australian Transport Safety Bureau was formed under I think it was a Liberal government, federal government, and it had some 50-odd representatives from all around Australia, including police, including other members that had an interest in road safety and trying to reduce fatalities on our roads. And he then went to Europe, and it's now in the International Transport, I've forgotten their ETAD, forgotten the acronym, what it represents, but he then presented to them and also to the WHO, World Health Organization, and now it's adopted all around the world. So it is a Victorian concept which has been taken by everyone around the world. So this is now the approach. In the US, it took us a long time to convince them, but they've also adopted it as well, just for your honest benefit.
Dr. Richardson, I haven't forgotten you. Do you wish to add anything to what you've heard?
No, I agree with what Associate Professor Logan put forward and presented.
Dr. Richardson, could I just ask you to explain, again in brief terms, the research methodology that was utilised by the Monash University research team? as part of the MUAC report?
Can you be a bit more specific?
Well, certainly.
Yes,
there was
because
a number of things that were undertaken. There were document reviews, there's data linkage reviews, there were surveys, there were focus groups, there were site visits. But in broad terms, looking at it holistically, which is what the research team undertook to do, and it appears did so do, you could just highlight some of those research methodology steps that were taken.
I'm reluctant to on one regard because I didn't lead that work. Dr. Carlin, you're the person that led that work. So
all right. I understand. Yeah. I won't take you into an area that you can't speak to or weren't involved in. The report will speak for itself. Coming to you, if I may, Professor G. Beda, in relation to the first 8 sections of the report, which it's a heavy report, is it fair to say that you thought that was good investigative research?
Absolutely, yes.
And that you have stated in your supplementary report that you commend the researchers involved for the work that they undertook and the excellent insight that they brought to bear in relation to the RFS work environment. Is that fair?
Yes.
What I wish to focus on primarily is the stage 3 aspect, which is the engineering review. And Dr. Richardson, if you're more comfortable, I'll ask you, what was the methodology that was deployed in relation to the engineering review?
It was the question we were put with is, conceptually, can you do something within the constraints of working within a safe system and the other aspects that were being investigated and being detailed? And conceptually, there is scope to at least explore and find out if something can be done, but there is no commercially available system that we could go out today and grab and put on there and retrofit. It's going to need some more engineering work than can you do something. And there's a range of elements of work that have been undertaken by other people, and I've undertaken, that from my perspective make it conceptually possible to improve the structure of the vehicle, to protect against both falling object protection and in the event of a rollover.
When you say that there's no commercial vehicle out there, is that in part because, firstly, there's no relevant design standard, and secondly, we're dealing with vehicles that operate in a unique operating environment?
Yes, but no one has really put this as an issue. I made the point before, it's the risk has to be identified, and while it can be theorised that the risk exists, there needs to be some evidence based that the risk actually is there and you can do something about it. And the issue about what can be done remains to be quantified in a safe systems approach. I don't doubt that you could put a structure on these vehicles to provide protection. The question is, how much is it going to cost in terms of mass and effective use of the vehicle? That needs to be quantified and detailed.
You refer to the risk. What is the risk that you're referring to? Are you referring to the risk to the occupant in a vehicle that sustains either a falling object or a rollover, or some other risk?
Yes, no, those are the risks that I'm, in terms of the engineering work that I've undertaken, those are the risks that I'm talking about. There is the consequence of that. So there's the unintended consequence that also needs to be considered of, if we put, for example, if we put a big, heavy structure that cantilevers over the top of the vehicle, how does that change the dynamic handling of the vehicle? That's a question that's out there. Empirically, from looking at what was done in Victoria, it changes it significantly. So that's an area that I would say is an unintended risk that needs to be evaluated and quantified in whatever is being done. And you need to design with that in consideration.
Associate Professor Logan, do you generally agree or not with what you've just heard from your colleague, Dr. Richardson?
No, I agree with Dr. Richardson, but I think it's important to note that the brief was for us to investigate whether a design was feasible from a conceptual viewpoint. And there will be several more steps involved in order to develop a system that's practical for use in the New South Wales RFS. And the reason for that, particularly with regards to the falling object protection system from a purely engineering viewpoint, is that we currently don't have a set of test criteria to test to. And what I mean by that is we can design for a log, the particular tree that fell on one of the vehicles in the rear cabin of the, I've forgotten which incident it was. I think it was the
Kearn Road incident.
It was the Kearn Road one. Yes, that's right. We need to understand what we're designing for. We can design for larger trees and heavier trees falling from a greater height, or we can design for what might be a typical tree. But until we know what we're designing for, it's impossible to design a system to achieve fit for purpose. So I think the next steps need to be to understand what we can define as fit for purpose, because we won't be able to design for every possible tree fall. We have to set a set of criteria that we can comply with, and then we can see what sort of system will be able to perform adequately under those conditions. And if we've selected those test criteria appropriately, then the goal will be to offer protection for the highest proportion of incidents that are likely to be encountered by New South Wales RFS crews.
You mentioned a moment ago that the engineering review has identified a conceptual plan, but there'll need to be specific testing criteria developed. Has the MUARC project come to an end, or is it likely to move into that next phase where you bring to life the concept that you and your colleagues have identified in Section 9 of the report?
The current project has come to an end, but we are talking with the New South Wales RFS about a future project to undertake the steps that I've just described, yes.
Thank you, Associate Professor Logan. Professor, do you have anything you wish to add to that?
Oh, possibly with regards to mass payload, I would suggest. The issue here is...
Pausing there. When you're referring to mass payload, are you in effect referring to the tanker and the capacity that the relevant tank can hold?
Yes, that's what
water.
Water. We're talking about life-saving water here. Yes, absolutely. And that is, I don't think we should consider this as a situation where we're trying to provide a rollover protection structure or a FOPS protection structure external of the cabin. To be fair to Dr. Richardson and Adjunct Professor Logan, they are considering and looking at the internal structure of the vehicle in terms of the cabin. I'm talking about the cabin and what you can see within the cabin. I think there is a lot of potential for that cabin to be strengthened properly. There was a major project about a decade ago on high-strength steels where they tried to reduce the mass of a vehicle and looked at all sorts of alternatives, including foam filling, including different materials, lightweight materials like aluminium. In the end, they concluded it's high-strength steels. And so the manufacturers have now turned to that. That was a successful program that was funded by the European Union. And we're talking about high-strength steels in the range of about 4 times that of current mild steel. And so that cabin needs to be looked at very carefully. I would, if I may indulge, I'm wondering if you could put up the figure 1 diagram from my...
Supplementary report?
Yeah, if that's possible to put that up on page 5 of my supplementary report.
Whilst that's coming up onto the screen, you referred to that particular steel that's being used in Europe.
Yes.
Is it being used in medium to heavy commercial vehicles?
I'm not sure. I'm not aware of whether Volvo are using it in their trucks or other Mercedes or other major companies. It's possible they may be, but these are commercial in confidence designs.
Obviously, Isuzu's not manufactured in Europe.
Yes.
But do you know whether it's using that particular?
I'm not aware. As you can see, Your Honour, this is a sports utility vehicle, and you can see there are holes throughout it like Swiss cheese, and there are sections in that roof which really would be the antithesis of good structural design. The profiles collapse. They can't transfer a bending moment load across the connections from the roof pillars to the side pillars. The better vehicles, such as, for example, Volvo, got rid of all those holes, made them slightly thicker walled, high-strength steels. And through that, they were able to then design a vehicle that could tolerate a rollover crash. It's available on YouTube. If you type in Volvo rollover, you'll see the test that was carried out. But that is also coupled with airbags, side air curtains firing to keep heads from going outside. The windows are appropriately laminated so that they don't crack open, so that limbs can fall out. Seat belts are pre-tensioned when it senses a rollover to hold you in, and so you then survive the rollover crash. The same could be said with FOPs if the structure was appropriately strengthened with high-strength steel. In terms of void filling, there's a bit of caution there, because if void filling was working, then we'd have aircraft wings full of foam. They're not. It's steel, high-strength steel. In aircraft, it is aluminium and composites. And so it's really smart engineering, understanding what thin-walled structures are all about under deformation. And so that expertise needs to come into this to try and pressure Isuzu to redesign their cabin so that you don't have to fit a FOPS or a ROPS, and that it could tolerate a certain criterion. Associate Professor Logan is correct in that you need a criterion. Without a criterion, we're just stumbling in the dark here. So that criterion needs to be established for falling objects, but also for the rollover. So, for example, in the US, these vehicles have now been, that I point to in Figure 1 here, are being subjected to a roof crush test, where a load platen is applied to the front, to the location where the front A pillar connects to the side header rail, and it's applied in such a way as to measure the load versus deflection. And so what they are seeking is that the load resistance is at least 5 times or 4 times the weight of the vehicle. So that's another criterion that could be applied in cabin strength. So I think that's a relatively straightforward one that we could work out. The FOPS one is more difficult because, what size of tree are you going to select? What mass? And so...
From a testing criteria perspective.
Yes, from a testing criteria perspective, but you must have a criterion, otherwise we're just shooting in the dark.
Just coming back, if I may, to foam filling, are there commercial vehicles, heavy vehicles in mining or in agriculture or in other industries where there's a risk of rollover or falling objects that have foam filling in their structure?
Usually they don't, because it's usually they use thick-walled members, and so they don't have the complexity of having to reduce weight, as in this case with the fire trucks, and so they can put much stronger members, thicker-walled members, which don't form this collapse mechanism, as we call it. And so it's certainly a much simpler problem for them. But here we need smart engineering to address this problem.
Because of the necessity for the payload.
Absolutely.
Can't lose that.
No.
But at the same time ensuring that the gross vehicle mass doesn't exceed a point where you may increase the propensity for rollover.
Yes, and also the fire issue. You don't want these...
That is fire protection generally in terms of fire.
Well, you don't want the composite burning. You don't want materials melting, and so it's really... so it has to sustain a certain temperature as well. High-strength steels meet that criteria.
Associate Professor Logan and Dr. Richardson, I'll come back to you on what you've just heard just now, but I apprehend that Your Honour, now might be a convenient time for the morning adjournment.
Take the adjournment and resume at 12.
I'll just check whether Associate Professor Logan and Dr. Richardson can see and hear me clearly. Thank you, Dr. Richardson.
Yes, we can.
Thank
Yep,
you,
I'm here.
Associate.
Seen here.
Right. Before the morning adjournment, Professor Gibietta gave a lengthy response to a question I asked, and in that response, he covered Figure 1 of his supplementary report, which dealt with the internal structures, and the Swiss cheese analogy covered high-strength steel and how that could be utilised, and foam filling. Coming to you first, if I may, Associate Professor Logan, do you agree with what Professor Gibietta said in relation to those topics, or do you have a different view?
In general, with the points that he was making, I think if I could just say at a high level, I think what we're really talking about here in summary is that there are multiple ways in which we can achieve an engineering solution. The first is to just use a straight add-on to an existing vehicle, like a FOP system bolted above the roof. But and of course there are compromises associated with all of them I won't go into. But then of course we can do an add-on plus some foam filling and some other minor modifications to the vehicle structures, which of course would need to be done after the vehicle has been delivered from the manufacturer to the New South Wales RFS. And that then allows you to take away some of the compromises of a bolt-on structure, because you can add some more strength, a limited amount of additional strength to the base vehicle, and then use an additional structure to reinforce that or to support that. And then, of course, as Professor Gibietta talked about earlier, is we could go for a completely redesigned vehicle. Now, that, of course, would be likely to be the best solution in the long term, but it is a long-term solution because it requires the vehicle manufacturer to redesign the vehicle and provide a different vehicle. And there are certain challenges associated with that. You have to be able to supply that vehicle, and it depends on the buying power of the customer in being able to demand a safer vehicle, and that's where standards would come in. So we can use some standards to guarantee a better quality of all of the vehicles that are supplied, and then if we have to supplement those standards, then it's likely to be easier to do so. We've got a better base vehicle. So I think what we're talking about are sort of a range of engineering solutions, each of which have their own benefits and disadvantages. But I generally agree with what Professor Gibietta has been talking about.
Thank you, Associate Professor. Coming to you, if I may, Dr. Richardson, do you wish to add to what you've heard from your colleagues on that subject matter?
I'd like to clarify some points. I agree in the general terms, and I think if you look at the way in which the report is presented, it's really, we're looking to develop in the next step, a range of criteria which can be used in future vehicles. How the manufacturer chooses to undertake that structural capacity, I agree, it probably will be with high strength steels and improving it. So I have no dispute with that aspect of it. The points I do wish to make though, is that, I'm sorry, but foam structures are used in aircraft. That's just wrong. Please look up a gentleman by the name of Bert Rutan. He's a well-known aircraft designer that has been using foam composite structures in aircraft for almost 25 to 30 years. He's built a range of aircraft. So the assertion that it's not used in aircraft is wrong. It's used in different ways in terms of composite structures in aircraft. So I disagree with that. The point of highlighting the vehicle in Figure 1 and making the point that has a different, or the rollover criteria, how SUVs or cars roll over is completely different to how trucks roll over. And trying to use a car rollover criteria for a truck rollover is also not helpful. There will need to be a truck rollover criteria for this, because clearly we're dealing with trucks and we're not dealing with cars. Cars tumble and can have multiple rotations as they go down the road, whereas trucks typically fall on their side and then may go onto their roof. The fundamental advantage that fire trucks have in their design is they typically have a big box structure that sits behind it that can be used to provide an element of protection to mitigate how much crush and deformation occurs. But there will need to be a criteria. And then it's about, if you do something for a new vehicle, you will be doing something for the fleet, but it will take 25 years to progress through the fleet. So What we're talking about doing is looking at options that could be potentially retrofitted to the fleet, and that's got to be a fleet management issue. And there's a different approach taken for new vehicles, or there's potentially a different approach can be taken for new vehicles as opposed to retrofitting vehicles that already exist. So there needs, again, some nuance in what's being put forward. I'm not disagreeing with the points that are being made, but I think there's more nuance that needs to be carried through on them.
Professor Givietta, do you wish to say anything by way of response?
No, it's fine. I'm in agreement.
Dr. Richardson, can I come now to the conceptual plans or designs that you've identified in the MUARC report? Can I firstly deal with the one that may be able to be retrofitted, and do I understand correctly that could be a reconfiguration of the headboard?
Yes.
And if you need images displayed on the screen as part of your response, please say so. But in general terms, could you explain what that concept entails?
The first premise is that you make the structure extend to the maximum possible acceptable roadworthy limits of the vehicle. So you put the points that you want to engage with the ground or any falling object as wide as possible and as high as practicable as you can. The headboard on the vehicle at the moment is tapered at the upper points, so it doesn't extend out as wide as it possibly can, and it doesn't extend above the cabin of the vehicle. So you have the potential, just by changing the geometry, to increase the effective area of where that headboard engages. And then it's a matter of some really basic structural design issues that can go with it. So that's the concept that I've at least put forward. And what it is, it's diagonally braced, and it's diagonally braced so that the upper cross member is supported for loads that come onto it. But those loads are taken to the chassis points of the vehicles. The previous structure, if you can go to the previous image. 1924. Sorry, that's the shape and the orientation of the existing structure that's on the fire truck. I didn't do an overly detailed analysis of it because it's the concept was to show that by taking, if I take that shape, which is consistent with what's on the structure, and apply loads to it to get it to fail, that gives me a load criteria at which this structure will fail at. And then by changing simply, instead of it being 4 vertical posts with an upper and a lower cross member, to being different, in this case, 2 vertical posts and 4 inclined triangular items that are braced, for effectively the same mass, you can get a much larger loading before failure occurs. And that's what it's just structural design, and looking from the structural design perspective is, with that mass, can I do something that's going to give me more performance? And the intent is to make it wider and make it higher than the cabin so that it engages with the actual, either the falling objects on the rollover before it impacts into the cabin of the vehicle. The other thing that I'd really want to highlight, these are that are a very thin inside profile, and there is the potential for them to hinge at their bases away from the cabin of the vehicle. And that is a feature that there needs to be some integration or some linking between this structure and the cabin of the vehicle to make them structurally connected. It can be a loose connection. It doesn't need to be a rigid locked connection, and the size and the extent of that connection, but it just needs to be a tension member when it's under load so that the structure doesn't fold backwards out of the way. There's an example of a Victorian vehicle that rolled over that has not a dissimilar type of structure, but essentially the headboard structure folded backwards and the cabin folded forwards because they're not interconnected. So that's a relatively simple system that could be implemented, could be retrofitted, but I'd make the strong point, you get a design benefit, but you have to also ensure that it's not going to hinge at its base and fold backwards. So you do that by putting a flexible linkage in there.
Thank you, Dr. Richardson. I'll just ask Professor Gibietta whether you wish to say anything in response to that answer.
Oh, no, I think Dr. Richardson covered most of the issues, but I still think that the original structure needs to be better analysed in terms of, I'm not sure if Dr. Richardson did any tensile tests on the actual headboard, the existing headboard, because that would mean extra costs in terms of retrofitting with a structure like this. And I think it needs more exploration with appropriate program, an elastoplastic program that we commonly use in crashworthiness studies like Alice Diner, and also some tensile tests of the material. What are we dealing with here? Is it a 250, a low-grade steel, or is it a higher grade steel? So I think that work needs to be done before progressing on to proposing a different structure, and whether you can actually retrofit with a little bit of bracing in the existing structure so that it wouldn't require that much work on existing vehicles. But I do agree in terms of the link between the headboard and the front cabin, and that issue of the headboard being pushed back. I think that needs to be solved, and I agree with that.
Do I take it then in terms of the geometrical design, you see sense in that?
Yes, I do.
And you talked about bracing may be an interim step in relation to retrofitting. Could you just explain a little bit more what you mean by bracing?
Well, Dr. Richardson showed in the previous diagram where the failure points were. Well, that might be overcome with some just small bracing in the actual structure to transfer the load a bit more to other members of the structure, because he pointed to the failure of joints, the external joint and the joint down below at the base, and so whether that can't be looked at a bit better. But you need a program. These programs, it's difficult sometimes to access them. You really do need a team. I had a team of people that were using Alice Diner, and likewise you need access to tensile testing systems, and you need to cut coupons out and get them tested to find out what the actual material, what material you're dealing with. So, for example, if that was high strength steel, one of the higher strength steel, then the loads would be higher at which failure would occur.
Dr. Richardson, have you done those testing that the professors just mentioned or not?
No, we haven't done them because what we were doing was demonstrating a concept. And all I'm doing in what I'm showing there is by changing the design conceptually and through a very simple method, you can get a significant improvement in the structural performance. That's what we were illustrating. If we're going forward, and what we've proposed in the next steps that are going on, what is outlined is what we are going to do. But to demonstrate, is there a concept that this can be done? I don't have to do the segmenting of parts. I don't have to do the tensile testing. I don't have to do the non-linear analysis, because the simple linear analysis shows that structurally there is an improvement by changing the design. All of those other parts, I can learn more and be more precise in the answer. I'm reluctant to accept that just by bracing it, because the existing cabin is smaller and below the roof of the cabin, you can brace it, but you're not going to get as much benefit if you extend the structure above and outside of to the widest width of the vehicle. If you do that, you will get more benefit. So I accept you can retrofit, but I really think the retrofit should be the replacement of the headboard to a much more structurally efficient system.
Moving, if I may, Dr. Richardson, to the next design concept, which involves a design in relation to the roof cavity and honeycomb a honeycomb type structure. Could you just explain that briefly to our honour as to how that concept may work in relation to occupant protection?
Yes, I have to pass some acknowledgements on, if I could, to Mr. Wilshire, who he'd proposed this as a concept as a result of a matter. Hang on, let me quote the right document. It was an incident that was covered by the IRC. Its number is IRC 19616, 2016. It was Nash versus Resources Pacific, and IRC 19632/2016 Nash Resources Nash versus Resources Pacific Proprietary Limited. The issue had been, in that case, could a FOPS be done? And it became an issue. A truck moved underneath a chitter dispenser on a coal mine, and 10 tonnes of chitter was let out of a hopper and crushed the occupant of a cabin. Could a existing FOPS or a FOPS to the existing design meet that? Fundamentally, I said no. Mr. Wilshire said, well, you could have designed a system, and he went through a range of work, and we did some things both in parallel, and he did a lot of work on looking at putting a crushable system. The issue became one of, is it commercially available? And there was nothing commercially available. I've held that in my back pocket from a whole range of work I've done to go, well, if there's ever a requirement to do an object falling on something, using Plascore or crushable aluminium honeycomb is at least one option that should be explored and can be explored. It's used typically in car crash test systems, and it's the crushable barrier that the cars run into to represent the crush stiffness of another car. It is a tunable material, so you can get it in different, and to use American terms, it comes in anything from, I think it's 25 or 10 PSI up to 70 or 80 PSI. So you can get it to be able to crush at different levels. So it's a tunable material. So we can put on the roof of a cabin, if the cabin can withstand the structural input, we could put on the roof of the cabin of a vehicle something that can withstand and absorb energy. Most FOPS, ROPS that are out there are not energy absorbing systems. They are rigid structures that take whatever load is put on them. You get an advantage in a vehicle putting a FOPS on it because you get the suspension of the vehicle and the tyres being compliant. If I can show a video of some ROPS testing, or some FOPS testing that I've undertaken of a vehicle, I'll give two examples if that's all right.
I'm in Your Honour's hands as to whether A, that is appropriate, and B, whether we can do it in circumstances where we've got witnesses joining remotely.
We might just have to see if it works. We could perhaps if we could.
If I can share.
Can he share his screen? Right, I think we need to hand over presenter rights so that Dr. Richardson can share his screen.
Oh, I see.
How long will that take?
I'll do it right now.
Oh, okay.
Mr. Freddie, you haven't had any?
I've got no issue with this.
Yes, thank you, Dr. Richardson.
Okay, I'm just pulling. What was that? I'm muting the sound just because I know it's not appropriate for all of the.
And before you do that, Dr. Richardson, could you just explain the provenance of the footage we're about to see and its relevance?
It's the test of a prototype system that I was involved in. So I'm the one that's filmed this. I'm responsible for the structure that's on top of the vehicle that has been initially inverted and dropped on its roof. So it's a vehicle that's undergone a rollover test and it's been dropped on its roof. And in doing this work for a range of different people, they also asked what would its compliance be against a FOPS test. The standard FOPS test involves dropping an object, in this case a 250 kilo item, from about 4.7 metres to get an 11.6 kilojoule loading onto the structure of the vehicle. So what you've got here is a foam structure that's been added onto the top of a vehicle that's then been, it's got a polyurethane coating on the outside of it as a concept of as a safety system that could be employed. And we were looking to see, well, could it also work as a FOPS? This was done in, I think, 2011 that it was initially done. So if I share the screen, hopefully you can see a vehicle. Its windscreen, which is a structural element of vehicles, has been displaced. There's a plastic hinge that's been formed in the above the driver's head on the A pillar. And if I just press play, there's a countdown, and then an object will drop from 4.6 meters that impacts it, and it survives the test well. There's deformation locally, but the structure, the roof structure, moves in and out. But that, to my mind, it's possible to do something in that regard. Stop sharing, and I'll pull up another one. So, having done that, as
just pause there. Sorry to cut you off, Dr. Richardson. Does it still remain a prototype?
We've built a range of different type of these structures and fitted them on vehicles around the world. It's a product that comes out of South Africa. I'm not doing anything in Australia with them, but they get fitted to a range of exploration mining vehicles and vehicles that operate in environments that have to comply with meeting a falling object standard. It well and truly met the requirements and probably exceeds it to a large extent, which gives me confidence that by doing something, especially if you can add a crushable element to the top of it, you will get much better performance. Now, that's what I showed you was to the FOP standard, which is 11.6 kilojoules. What I'd like to show you...
Before you move on, a few more questions, if I may. Has the results of the testing, which we've just seen on the screen a moment ago, have you published those results?
No, I haven't put that forward. It's really used in the commercial environment, and it's not something that's been something that I've published or presented.
And to the extent that it's relevant, does it meet any applicable Australian design rules or Australian standards or international regulations to the extent that they may be applicable?
The FOPS criteria as it exists at the moment, which is the FOPS criteria that if you went out and bought a FOPS on a vehicle today, is the international standard on FOPS. It meets that.
Thank you. I think you're going to show a second clip. And again, if you could just explain the provenance of this footage and its relevance.
Again, it's the same vehicle. So as a group of engineers, having seen it well and truly work to meet the 11.6 kilojoule criteria of absorbing and accepting energy, we raised the structure to as high as possible, which was 13 meters, which gives us about 30, I think it's about 38 kilojoules. So 3 times the energy requirement. Is it possible to do something? So I'd put in the context, this is a vehicle that's been dropped on its roof. It doesn't have structural support in the A, B and C pillars. It has a foam structure added to the roof of the vehicle. A foam structure added to the roof of the vehicle. If I open that, sorry, I've just got to pause, and if I share. So this is being dropped from, this is 3 times the height as the previous one. It's dropping. And what I'd ask, I'll probably do it twice and show. Certainly more roof movement deformation that occurred in that regard, but probably what I'd ask you to look at is how much the actual suspension and the compliance of the vehicle goes with at impact that occurs. So in terms of making a FOPS structure, I believe it's possible to do something. That gives me the confidence to say what we've said in the documents, that by stiffening the roof of the vehicle and potentially putting an energy absorbing structure on the outside of it, you can meet a much greater FOP standard, because this is going well and truly beyond the FOPS criteria that's published, and could go to the levels that the Victorian fire vehicles have been built to, and the performance that they're achieving, which is 55 kilojoules. But again, we're back to the point that something needs to be done. I think Associate Professor Logan has something to say. And do I have to do something to give rights back, or will you take that back from me?
I think we're now in the cockpit, so to speak. Before I move to you, Professor Givietto, can I just ask you, Associate Professor Logan, whether you wish to add anything to what we've just heard and seen?
Yes, I would like to just put what Dr. Richardson showed in context. I think it was fairly obvious from those of us watching the video is that was neither a tree that was, nor was it a heavy vehicle. What Dr. Richardson was intending to do there was just to demonstrate the overall concept. And I think I'd just like to reinforce again that in order to develop a system for the New South Wales RFS firefighting vehicles, it would need to be a custom designed concept and designed with particular loading requirements, and therefore the test criteria that should be developed in order to ensure adequate performance for those vehicles.
Thank you, Associate Professor. Coming to you on this topic, finally, Professor Givietto, do you wish to say anything from what you've just seen or heard in relation to the use of a foam external structure?
I have nothing to add in regards to that, only consideration for added weight at the roof height level as to whether, and I think I'm familiar with the material that Dr. Richardson's referring to in terms of the crush profiles, and I think they're made out of aluminium, so they're quite light. But yes, it has great potential.
Professor, the MUAC team have recorded in their report that the installation of an internal roll cage is not recommended because such solutions reduce occupant space, which apart from hindering ingress, egress and occupant comfort leads to a higher incidence of occupant contact, particularly with regard to the risk of head strike during vigorous vehicle movement or during a crash. Do you agree with that sentiment?
Yes.
Now, to the extent that it hasn't already been covered, I just want to return to the engineering limitations, particularly in the Victorian context of the two vehicles that were displayed earlier, and I'll just have those brought up again. I apprehend, Dr. Richardson, in large part you may have already covered this in an answer to an earlier question by me, but I'll go to you first, if I may, Dr. Richardson, just to identify or elicit from you your observations as to why those two particular vehicles, which have protective systems, may either have limitations from an engineering perspective, or secondly, may increase risks, be it of rollover propensity or some other risk.
I think they meet and they will probably exceed the design criteria that is intended for them. In terms of they're designed to absorb 55 kilojoules, essentially a segment of a tree dropping across, along and diagonally across the vehicle, and protect the occupants of the cabin of the vehicle. I believe that they will achieve that aim and do it, if not exceed it. The design features that are in there make that, to me at least, plausible and likely, and I've seen some of the reports that detail how the design was undertaken. So I'm not disputing that they can achieve what they're designed for. The issue is the mass that it then adds up, and that it adds mass high, specifically above the cabin of the vehicle. Vehicles are dynamic pieces of equipment that move on roads. How high the centre of gravity or how high the mass is placed affects it both in terms of the centre of gravity height. The higher you put objects, the more you raise the centre of gravity of the vehicle. The other thing that it does is it changes the rotational inertia about the roll axis of the vehicles that make how it dynamically behaves more of a problem. I think that in doing a ROPS FOPS criteria what you should be also doing, and we've made this in the documents that we've presented to RFS, is that you should do a baseline test of your vehicle, a dynamic handling manoeuvre analysis test. You should do a dynamic test of the baseline vehicle and the vehicle that you modified to make sure that what you've not done is make something really scary to drive compared to something else. This is to a car where you have cars on the roof of the cab above the vehicle. Not as much mass as a car, but it changes the dynamic properties of it. Safe, but it has mobility issues that in one regard will make the operators more cautious, but in the other regard, it makes it the potential of being involved in a rollover dramatically greater than other alternatives that could be applied. So in the systems we've looked at and concepts that we've tried to put forward, mass and the height of the mass and the structure that you're putting on is a significant consideration.
Associate Professor Logan, do you wish to add to that last answer by Dr. Richardson?
Yes, I think what Dr. Richardson's saying is that it just simply emphasises the need to look at these solutions holistically. If there is a FOP solution or whatever FOP solution is adopted and or ROPS, it will definitely change the dynamics of the vehicle, and there may be some changes to the dynamics of the vehicle that are unavoidable in order to provide that additional protection from falling objects from above. So what that will mean is there will need to be changes in the procedures used to operate the vehicle and a program to make sure that the drivers of these vehicles are fully aware of the changes and any operational changes that are necessary in order to avoid exceeding the rollover thresholds of vehicles under as many operating conditions as possible are carefully understood and specified and communicated to all firefighters who will be driving these heavy vehicles.
Simply put, Associate Professor, it comes back to the holistic approach having regard to the concept of a safe system for road safety.
Yes, it does.
Professor Gibietta, what, if any, observations would you like to make in relation to this subject matter?
I'd just add one more point to what has already been said, and that is that we need a criterion for rollover. We don't have that in the Australian legislation, and so New Zealand have defined it as the lowest that they will allow for a static rollover threshold. That is where you test the vehicle with load cells. You place one under each wheel. You raise the vehicle up to determine its centre of gravity, but you also then can work out what its stability ratio threshold is. And so they've set it at 0.35, and we definitely shouldn't be going lower than that. But the point here I'm trying to make is that we need a criterion for that as well, so that we don't lose potential in terms of using any system that we develop.
And to have a criterion, do you need an Australian standard, essentially?
Yes, potentially. Yes, it would be good.
And you've made...
Or an Australian design rule.
You've made a recommendation in your reports touching on that concept. In practice, how would that work? How does one, be it in an industry or through academia, come together to advocate for either a new Australian design rule or for an Australian standard?
Well, you have to put an application into Standards Australia. There needs to be someone or an entity that has a desire to make that happen. In other words, there's some funding that's required. Standards Australia have very limited funding. And so usually it's some group. It could be the New South Wales Rural Fire Authority, Service rather, or the there's a committee, I think, of firefighting groups, AFAC or something like that, and they could potentially chair that particular group of experts. And you bring in all of the experts, including the government representatives, the workplace representatives, the fire authorities, and experts such as we three, and then you come to a consensus. And that's the point, is coming to a consensus, because engineering systems are complex. But it would be good to do that. And that's where such criteria could be established.
And would it then follow on the assumption that there is a criteria that is rigorous and it's established and it's accepted? Could that then be taken to a particular manufacturer to have a purpose-built fire appliance?
Yes, there's one problem, and that's the ACCC, I'm afraid, and they would have issues in regards to importing of products, and so it's a restriction of trade. There's issues with regards to that, and so we've had that in the past with trying to introduce standards which are more demanding, let's say, of products that are coming into Australia. So it's best to be in harmony with Europe and the US, where the manufacturers are faced with the same type of legislation, and so that's really the bottom line there. So Australia can't be out on its own demanding stricter criteria. I mean, it just, as Associate Professor Logan said, it depends on the demand for products.
Purchasing power. Purchasing
power is the bottom line. We have successfully done this with police vehicles a couple of decades ago. That happened by negotiating various purchase of various vehicles that had better protection for officers. That happened some time ago, and there is history. But and likewise with the quad bikes, we did exactly the same with the quad bikes, and so there is some history, but resistance can be strong from the manufacturers sometimes. And so, as I said, it's got to be a consensus. If you're going to produce a standard, or an Australian design rule has to go through a RIS, a risk. I've forgotten how it's called. It's a RIS, rather. You assess whether you're going to lose any profits or you're going to restrict markets, etc., and the government has to do that. Regulatory impact statement, that's what it's called. My apologies.
Apart from that matter, are there any other areas that you think there's scope for recommendations to make occupants of fire appliances more safer that hasn't already been covered today?
I can't think of anything that we haven't covered so far.
Associate Professor Logan, we have before us section 11 of the report, which sets out a number of recommendations. We've canvassed those today. Do you have a view in relation to the feasibility of a new Australian design rule or an Australian standard in relation to better fitting fire appliances to deal with occupant safety?
The points that Dr. Crocibieta makes are all valid points. However, I think if we're looking at an Australian design rule, that is not one that will be specific to fire appliances. It's likely more to be a general heavy vehicle regulation, which means that there are two ways. We could try for a standard amongst AFAC, for example, that just applies to firefighting appliances Australia-wide, but that's going to be more specific. It's likely to be a more stringent standard because it will be referring to firefighting requirements, falling object protection in particular. However, an Australian design rule is likely to be of a lesser standard because it's going to be applied across every commercial vehicle or every medium rigid vehicle, for example, brought into the country. So we need to make sure that we're advocating for the development of a standard that is applicable to firefighting vehicles, and it may well be that it'll increase the minimum performance of these vehicles, but there may still need to be additional requirements put in place for firefighting duties specifically. That's the only caveat that I would add to those comments.
Dr. Richardson, what's your position in relation to the feasibility of an Australian standard, or what you've just heard in relation to an Australian design rule?
I'd really reinforce what Professor Logan has said in terms of the other thing that I'd flag is the time that it would take to get a standard in place we're talking years, not weeks, not months, but years of effort will be needed to get the consensus that is being put forward, or at least that needs to be agreed with. So you're going to need to get, not only amongst the fire services, if you go for the fire service standard of getting Victoria, New South Wales, Queensland, Tasmania, New Zealand to agree on what's going on. You're going to have to get the West Australians. Everyone's going to have to agree, and then you're going to have to get more agreement if it goes outside of just being fire trucks. I think it's a laudable idea, but I think that there's scope and what we've presented and what MUARC's proposing to do. They will get to a point where they do a lot of the work. It could be used as a template for a standard, but there is work that's being undertaken now that could lead that rather than wait for it. I wouldn't be endorsing that we now wait for a standard. I would be saying that a standard could be developed in the future, but it's going to again come back to the criteria, which is essentially the first step of what we've proposed we need to do as the next step in the MUARC work.
And the final topic I wish to ask each of you about is that we've seen some examples of FOPs and ROPs in the Victorian context. Dr. Richardson, are you aware of anything that's been done in that area in North America or in Europe?
No, I'm not.
What about you, Associate Professor Logan?
I haven't looked into that in great detail, but at this stage I'm not aware.
And finally, Professor Gibietta, are you aware of whether there's been any developments in North America or Europe in relation to fire appliances?
Other than what's been cited already in everyone's reports, no.
And that concludes my examination.
Thank you. There may be other questions. Mr. Free.
Thank you, Your Honour. Just briefly, Dr. Richardson, can you hear and see me?
Yes, I can hear you. You're a very small figure in.
I'll take that literally and not figuratively.
No.
Dr. Richardson,
Sorry.
I just wanted to bring you back to a comment you made towards the start of your evidence this morning when you were asked to comment, I think, on the question of fitness for purpose of vehicles, and you said you wanted to make some comments about what fit for purpose means and how you make that assessment. Can you perhaps just develop that for us?
There's an Australian standard that relies on risk assessments, and you're looking at both the consequence, what happened, but how often or have these types of events occurred, what's your committed history. So I think having seen these events and the circumstances that have occurred, you can identify what risks are and what needs to be done. But could have someone have done that prior to the event? I think the people in the room or the people that you're speaking to will say, well, we'd looked at it, we could have seen that, but there wasn't the evidence of the rollovers and the injuries and the rollovers or the falling objects onto vehicles to the same extent. So to put the context of are they fit for purpose, I think it's in a very specific criteria in where the trees can fall over. That needs to be looked at in that context and how you manage it. And if you can't put an engineering solution in to manage it, you're probably going to have to do some procedural changes and modify the way in which the equipment is operated or the criteria on when it goes in and when it doesn't go in. So that's a more operational fire service question about how they deploy the vehicles. I just don't think, I don't agree that you can label them as being unfit for service across the board. It's in the circumstances that they were exposed to, they have been shown to be structurally weak and not performed. So that now leads to the point where something needs to be done about that. But could have we made those decisions 20 years ago? Possibly, but then we've got to predict that we don't have any evidence of these types of events, or unless we do have evidence. But I haven't looked at that aspect of it. But that's where I'm being cautious about saying they're unfit for service. So I'd just be quantifying that.
Thank you, Doctor. And the upcoming work that MUARC has proposed in terms of identifying testing criteria to feed into more design work, does that feed into a more general assessment of what vehicles will be fit for purpose?
If that's a question, that's going to be a question that we're going to be able to quantify in terms of here's a baseline performance of the vehicle, here's what a modified vehicle looks like. It's then going to be an issue for the fire service to make decisions about what vehicles they put in what locations, or what exposure. Like the vehicle that ran into the falling tree at 70 kilometres an hour, I think I'd get agreement. You're not going to be able to design a system that is effectively being able to retrofit to a vehicle that would provide protection in that event. It's just too exposed. So it's the nuance of what's being asked and looked at. So it is in the detail. I'm sorry we're going to have to look at the detail, and we're going to have to get good criteria that give us representative falling object impact test criteria and good rollover criteria that is applicable, I would say, applicable for fire trucks, that we utilise to evaluate structures and then design structures. Once those criteria are developed, they can be applied to anyone future purposes as well as retrofitting.
Thank you, Dr. Richardson. I'll just give your colleagues an opportunity to comment, starting perhaps with Associate Professor Logan. Is there anything you wish to say on the two matters I've raised with Dr. Richardson?
I don't.
Thank you. Professor Gibieta.
I think I'd just like to add that at the moment there's a vacuum. We don't have any criteria, and it's important that we do have a criterion because, as I pointed out in my report, when everything fails around the firefighters, the last resort they have is these systems which will save their lives in these adverse events. And so whilst the risk may be low, given that we have a safe system approach to road safety and to the workplace and the hierarchy of controls, administrative controls are important, absolutely, but they work in harmony with the fail-safe systems that back up in case those administrative controls fail. So that would be the point I'd add.
So, Professor, does it follow from that because there is that vacuum in terms of the criteria, you can't make an assessment of fitness for purpose because you don't have something to measure against?
Yes, I'd agree with that.
Thank you, Professor. Excuse me for a moment. Thank you. No further questions, Your Honour.
Thank you. Anything arising?
Nothing arising. Thank you, Your Honour.
Thank you very much, each of you, Professor Gibieta, Dr. Richardson and Associate Professor Logan. Much appreciated. You're all excused.
You're welcome. Thank you, Your Honour.
Your Honour, there's one other witness remaining today, and that's Deputy Commissioner Stewart. I'm in Your Honour's hands as to whether you want me to call the Deputy Commissioner now. I do need a little time because I just need to check that in effect a PowerPoint presentation has been loaded and can be shown.
I think we'll take the lunch adjournment and resume at 2 o'clock, or would you like to come back a bit earlier?
I don't mind if it's 10 to 2 or 2.
Come back at 10 to 2.
Thank you, Your Honour. Your Honour, I call Deputy Commissioner Carl Stewart, S-T-E-W-A-R-T.
Silence, please. Do you solemnly and sincerely declare and affirm that the evidence you shall give will be the truth, the whole truth, and nothing but the truth? If so, please say I do.
I do.
Have a seat. Thank you, Commissioner.
Deputy Commissioner, would you please state your full name, present occupation and your professional address, please?
My full name is Kyle Stewart. I'm a Deputy Commissioner of the Rural Fire Service and my work address is 4 Murray Rose Avenue, Sydney Olympic Park.
And as a Deputy Commissioner with the New South Wales Rural Fire Service, what area of operations are you primarily responsible for?
The directorate that I head and lead is the Preparedness and Capability Directorate. It supports generally field operations and all that is required of the firefighting community that is within the RFS.
Before we proceed further with your evidence, is there anything you wish to say to the family of the gentlemen who lost their lives in relation to the 3 vehicle incidents we're concerned with today?
Look, very much I'd like to offer a message of condolence with your indulgence, Your Honour. On behalf of the RFS, I would like to offer my deepest and most sincere condolences to the family and friends of Samuel McPaul, Jeffrey Keaton and Andrew O'Dwyer. The tragic loss of these men has had a profound impact on the New South Wales RFS and the community at large. Their bravery, dedication and sacrifice as they kept us safe in the face of what was arguably the worst fire season in our state that it had confronted at that point in time stands as a true testament to the character of each. Whilst I know the grief that the RFS family and the broader firefighting community feel at the loss of Samuel, Jeffrey and Andrew is incomparable to that of the loved ones they left behind, it is nonetheless a very genuine grief and one that is never far from the mind for us all. These men will not be forgotten. The names of each is now included on our wall of remembrance at the State Training Academy. To the family and friends of these heroes, please know that by this very simple act, their story and their sacrifice will be remembered and will forevermore be a part of what drives the organisation I represent. Although I did not have the honour of meeting these men, I know a little of their stories and a little of the loved ones they left behind. As a community, we are clearly in their debt. I know this debt will remain and can never truly be repaid, but my hope is the family and friends of Samuel, Jeffrey and Andrew know the RFS will always be there to support them. Thank you.
Thank you, Mr. Stewart. Do you have before you your statement dated the 14th of March 2023? If you don't, we can make a copy available to you.
Oh, yes, I have a copy of that.
Whilst you're turning that up, you've provided a number of items of correspondence to Her Honour in relation to matters concerning vehicle design and safety. The first is dated the 7th of September 2021, the second the 16th of March 2022, the third dated the 24th of October 2022. I don't wish to take you into those. I'm really concerned with the matters that you've raised in your most recent statement of 14 March 2023. Are there any corrections you wish to make in relation to that statement, Deputy Commissioner?
No.
Now, can I have brought up on the screen a PowerPoint presentation, and I'll tender the document in due course, Your Honour. But what I'd like to do firstly, Deputy Commissioner, is just if you could set the framework within the RFS of how many vehicles you have, what their capabilities are, and then moving towards whether or not you can buy a fit-for-purpose fire appliance off the production line without having to do any modifications, or whether there's a number of steps in the process before you can have in the field a new or modified firefighting appliance.
The document that you see displayed before you was an attempt to represent in a fairly simple terms what is a rather complex environment in terms of the fleet that we operate within the RFS. Your Honour, we have, as you'll see there, as at last Friday, 4,017 firefighting appliances within our fleet. Those appliances are broken into 4 key categories that are governed by pre-2004 build dates. The builds that occurred between 2004 and 2007, and then those that were built between 2008 to 2012, and then those that were built from 2013 onwards. There are a number of dynamics within each of those broad categories that describe what are the design nuance that has led to the evolution of the various categories of our appliances. Your Honour, within those 4 base profiles of the fleet, there are a range of categories of appliances that perhaps measure somewhere in the several dozen at this point in time. Those categories of appliances are generally referencing what it is that's the capability offered by the appliance. One of the things that we saw represented through the investigations of the Monash University Accident Research Centre, and indeed was reinforced by Professor Gisbieta today, was that within the dynamics of our fleet, the ability to comprehensively influence a safety modification or design upgrade is challenged by the depth and breadth of the variations within the fleet that we have, be it within subcategories of each head category, or be it just with the broad number of categories that exist within our fleet more generally. Your Honour, on the screen in front of you, you will see that within the profile of our fleet, we have circa 499 appliances that are older than 25 years, and it's the target that we try and achieve to ensure that those principal firefighting appliances are retired by that 25th year of their service. You can see that there are a number of appliances that are certainly well beyond that 25-year mark, 70 or so are older than 30, and 3 are older than 40 years. Now, let me assure you that those much older appliances are not generally considered to be our frontline firefighting appliances. They are the kit that support our front firefighting appliances. They could be bulk water carriers or something of that nature. Your Honour, one of the call-outs that has been referenced during the proceedings here is that the bushfire inquiry through Recs A and B of subsets A and B of Rec 40 called out the need for us to comprehensively overhaul and refurbish those older appliances that did not have the most modern, up-to-date crew safety systems from a burnover perspective contained within them. And we have within our activities of fleet upgrades, we have a substantial operation that is currently being progressed in an endeavour to see that those appliances that still have some useful life within them have not only that useful life, but have the best available crew safety system from a burnover perspective in their design. You can see that, Your Honour, on that page, 1,160 of those appliances have a useful life but require crew safety protection upgrades. The task in and of itself has seen us being able to, since I think it was the 21 financial year, upgrade something like 100 of those, given the dynamics of the industry that exists out there to support those crew upgrades. Your Honour, we have within the profile of the fleet 1,782 appliances that are older than the 2008 build period. That 2008 timeline is a definitive break in the type of appliances that we built, given it was a design change time that was delivered upon us by the manufacturer from whom we obtained most of our principal firefighting appliance platforms. And from that point on, I think if we were to go to perhaps the third page of the, and what you see represented in that graphic, Your Honour, is the breakdown of those age categories of vehicles and what it is that the crew protection systems that are offered in that age category, and then what it is that were the principal other safety systems that you see that are attached to each of those platforms. And I've just, from a graphical perspective, put into that PowerPoint slide the Category 1 Isuzu design change that is the point at which safety systems, including the driver and then passenger airbag, as well as the current structure heavy headboard, and then the referenced ECER 29 cabin designs that was referenced this morning from the EU form a part of the basics and fundamentals of our appliance design from that point.
Thank you. Now, I might just have brought up some photographs of particular categories of appliance that are within the fleet. The first one is Category 1, and this is taken from your statement at page 1663 of the exhibit. Now, does this type of category, the Category 1, reflect about 50% of the fleet?
It does, Your Honour. We have categories 1, 2, 3 and 4, which are all a very closely related categorisation of this type of appliance, but this type of appliance is responsible for just on 50% of our fleet.
And what are some of its capabilities such that it occupies nearly a majority of the fleet?
It is our principal firefighting response appliance. The principal platform comes in two key variations, single cab and crew cab. Single cab being, as it sounds, driver, passenger and perhaps an observer. Crew cab allowing for a greater number of firefighters to be able to respond. It is principally designed as a bushfire fighting and forest fire fighting appliance, holds somewhere in the order of 3,000 to 4,000 litres worth of water, and has a pumping capacity that enables the firefighters to deliver that quantity of water into the fire ground for a range of purposes, be it grass firefighting, be it that forest firefighting environment. There is also a design that sits within this particular category of vehicle that is built for village and or structural firefighting or support of fire rescue activities. It is not uncommon to find this type of appliance in support of the pumpers that are rolled out by fire rescue into principal structure fires. But broadly, this type of platform offers the capability that is seen really quite broadly, generally needed across the state, which is why it occupies, such a large component of our fleet.
And looking at that image now, Deputy Commissioner, what modifications, if any, does the RFS need to do to that when it comes off the production line to make it fit for firefighting activities?
They are quite substantial. Over the course of the life of this agency, Your Honour, the production of a fire appliance has taken the form of us as an agency being integrally involved in the production of the appliance. This morning there was a number of references to purchasing power that is offered up through bulk purchasing through commercial arrangements. As an organisation, what we have discovered is that there is a very small industry indeed where you can go and buy off-the-shelf fire appliances. It's important that we still, at this point in time, engage with principally 5 companies that build a fire truck for us. But before it comes off the production line of that particular company, we as an agency will negotiate with, in this instance, Isuzu to purchase the cab chassis platforms. In a very shortened or abbreviated version of what occurs then, that platform is delivered to a dealership onshore in Australia. That dealership will then engage in several months' worth of fire spec modifications to the appliance. So anything that's effectively plastic and or that is vulnerable to fire is then retrofitted through that particular dealership. That dealership will then deliver that appliance to the company that we use as the principal constructor of the appliance. We provide that constructor with the pumps that go onto the truck, the fire blankets that go onto the truck, and a range of other bits and pieces that are necessary for it to roll off the production line in the version that you see displayed. So we are, whilst we are a customer of that producer, we're also integrally involved in their production activities and have a niche part in what I have often said is a rather bespoke industry in this particular country. One of the things that we do is we use the ability that we have got to approach an Isuzu or a company of that nature to negotiate opportunities for improvement and benefits broadly to our fleet. But it does come to the point that there is a real complexity in terms of having that truck roll off in the form that it is. It's touched many times before it ends in this particular format.
Thank you. Can I just ask you to have a look at the headboard of that vehicle, and then I'll take you to another image, which is the Category 7 vehicle, which is found at page 1669, Deputy Commissioner. That's the next popular category of appliance within the RFS fleet, occupying 33%. Again, can you just identify some of the significant advantages of this type of appliance in the field?
So the Category 7 is a smaller brother sister to the Category 1 by very nature. It's a vehicle that has a gross vehicle mass of circa 7.5–8 tonne. It is designed principally for a rapid response into harder to get at access areas. So the fire access via trail system that the RFS uses to access remote areas is a complex and intricate part of the firefighting world and is not necessarily opened to access by the Category 1 tankers. They are often not even able to be accessed by the Category 7, which is why we then have the, in part, the Category 9 quick strike appliance. This particular appliance comes with a far lesser water capacity on it, so it's around that 15 to 2,000 litres. The appliance itself has a smaller pumping capacity and is broadly in those smaller communities where the risk of fire is matched to the capability that's offered by this particular appliance.
Now, coming to the question of headboards, and you'll see this one has a slightly different headboard to the Category 1 appliance. When the RFS receives either a Category 1 or a Category 7 off the production line, is the headboard in situ, or is that something that's done by way of modification by the RFS?
The headboard and all of the bits and pieces that are effectively you see on the back of the truck are actually built by the people we contract to put the truck together. And so once we get it, it is as you see it there on the image.
Were you in court earlier today when the three experts gave their concurrent evidence?
Yes.
And do you recall a discussion in relation to headboards?
I do.
And based on your role within the RFS, do you see an advantage to the types of headboards that we see in the Category 7 or the Category 1 to offering some rollover protection?
Look, I do. Your Honour, we have embedded with our fleet operations team about half a dozen engineers, most of whom are firefighters and operate these appliances. So I have a real benefit in the advice that they provide us. We know that the headboard as produced has been standard fare on our appliances, our Cat 7 and Cat 1 appliances, since about 2008, with a few small but minor variations over the time. We know that there have been a number of instances where those appliances have been unfortunately subjected to rollover activities and that the headboard has in fact worked as intended.
Moving, if I may, into the NEWARC report, did that collaboration between New South Wales Rural Fire Service and Monash University come about as a direct response to recommendation 40, A, B and C from the New South Wales Bushfire Inquiry? Or was it, and has that come to its end in terms of the project that was undertaken by Monash University?
The current phase of it, this research phase of it and recommendation phase of it, certainly has closed out, as I think Associate Professor Logan referenced, but the further engagement of Monash is well underway in terms of what ought to come next, as was referenced by the three experts this morning.
One of the recommendations that was made by the Monash University team, of which there are a number, but dealing, if I may, with the more relevant one, which related to engineering solutions, the recommendation was that New South Wales RFS firstly establish a fit-for-purpose set of rollover falling object test criteria, and B, assess potential engineering solutions in an experimental setting. Are you able to give Your Honour any indication as to whether that recommendation is likely to be implemented?
I can give you an absolute assurance that it will absolutely be implemented. There is a true need for us to understand what it is that is the performance criteria of, FOPS, ROPS protective mechanisms, and as I saw today and as I've seen in the reports, there is a significant complexity in that very question, and we ought to have the answer to it.
And are you able to give any indication, Deputy Commissioner, of the time for the implementation of that next phase, which is the implementation of the various recommendations made by the Monash University team?
In respect of the engineering solution recommendations that they've made, the work around what it is that will be the test criteria for ROPS, FOPS, that will commence as soon as we can get the final engagement contract signed, and that is a work in progress right now. The dynamic of the testing in and of itself, the target is to see it concluded through the course of the 23-24 financial year. There is a dynamic about that which aligns with funding submissions through to government, and then ultimately to inject whatever the design parameters would be to the marketplace engagement for the orders that we would place for a new firefighting appliance.
And in terms of any retrofitting in the interim period, we heard some evidence today in relation to the headboards. You heard what Dr. Richardson and Associate Professor Logan have said in relation to a redesign of the headboard. You also heard what Professor Gibiata had to say in relation to some bracing. Are they on the table, so to speak, in relation to retrofitting to at least perhaps widen and raise the headboard and have different geometry?
Without being tried, I don't want to rule it out before I rule it in, but the internal engineering team has made the absolute observations that the experts did today in terms of unintended consequences of re-engineering things and needing to truly understand that. One of the dynamics that I guess needs to be put into the record today is that the headboard as designed is about ensuring that the headboard itself does not impede the ability for the Category 1 appliance to get into those tight spaces. So we heard today that there was a suggestion that the headboard be widened out to the max and extend its height over the cab environment. That would do some interesting things in terms of the fire trail access potentially that we would want that particular appliance to navigate. But importantly, one of the other stop points that we have got in the design process is that we contract with our builders at a regular point on an annual basis, and we contract with them to a particular design. Importantly, we engage with the designers that work in those builders' factories as well to understand what we can and can't do from a contracting perspective, from a practical perspective. So there will be a point where once we have settled what it is that we can do to retrofit without any real consequence to the performance of the appliance itself, then we'll inject that into the next iteration of our design.
I just wanted to raise one matter that I'm informed from the Auditor General's report, and it says this, that the Next Generation Fleet Priority Project launched in 2021. This comprehensive project is studying the existing heavy tanker fleet to identify opportunities to enhance vehicle operability and safety, deriving new prototype firefighting appliances of the future. It goes on. Is that next generation fleet priority project separate to the MUARC project, or is it a subset of the MUARC project?
Look, it originally had its origins as a separate project, so both are within my responsibility. They are now one and the same project. The next generation fleet project itself was simply as it sounds. It's about understanding what the opportunities are to innovate in firefighting appliance design. We have, at this point in time, progressed that project to a point where we've surveyed our firefighters, of which I think there was 45,000 active firefighters in the RFS, and about 7,000 contributed to the survey and gave us a true appreciation of what they saw worked, what didn't, and what looked promising in the firefighting appliance design world. What we have also truly understood is that the industry and the tertiary sector are out there ready to accept a challenge of taking what it is that we think would work in firefighting appliance design for next generation and presenting back to us what it is that a design might look like. We have engaged with a number of, and I'm being a little sort of careful in terms of the language and identification of the agencies that we've used, but if I said commercial truck builders who also have a firefighting appliance slant, we have engaged with them and stepped them through what it is that's the concept of how they might interpret what we think would work and what would be innovative in terms of firefighting appliance design, crew safety systems, and how they could then interpret that and deliver a prototype for us. So that will very carefully and very importantly take into account the consideration around the engineering question that has been put onto the table here around ROPS and FOPS.
You've identified in your statement some of the safety, you referred to safety benefits and risks in relation to the Victorian SOPs and FOPs, of which you've seen some images, no doubt, this morning. What do you see as the risks? We've heard what the experts have identified as potential risks in relation to the design of those two appliances utilised in Victoria. What do you think the potential risks are of that type of arrangement?
Look, I think if you if you look at what it is that they are, the experts called it out reasonably clearly today. They provide, in my language, slips, trips, hazards. In forward impact collision moments, you will find that there's going to be another thing that the firefighters inside the cabin can hit their head on if it's an internal roll cage. I absolutely see that there is a weight issue that attaches to all of the falling object protection designs that we saw in the experts' reports and displayed today.
When you say weight issue, do you mean a weight issue on the front axle? Or?
Absolutely, and then impacting broadly the GVM, which means that we will have to find a saving somewhere else. I do think that for me, one of the moments when you see the cantilevered solution on top of the Unimog, which was that Mercedes-Benz appliance, suddenly the centre of gravity of that thing has shifted northward to a substantial degree. And one of the experts today said that takes then a whole retraining point for your driver and operator of that appliance to understand the handling characteristics of it. Noting that both those appliances are built for forest firefighting. They are a part of that particular environment. That's their principal responsibility. And I get why they are constructed the way they are, but that's not necessarily transferable on to a Category 1 or a Category 7 grassland firefighting appliance.
You heard some evidence from the experts in relation to advanced emergency braking systems. What, if any, limitations are there in relation to the installation of those within the fleet?
Look, again, that would require a retrofit because I think we call out that AEBS is not a part of the ADRs and or a part of the general build of our principal appliances, which I think you call out, come out of Japan. It would require a substantial retrofit if that were to be something that occurs. The utility of the AEBS is something also that I'm not entirely sure would match the capability requirements of our fleet. I think.
Could you expand on that? Is it because of the operating environment that they would predominantly be in? Namely,
Indeed.
perhaps grass fires or rough terrain?
And indeed, look, I think Professor Grisbietta reversed from an earlier position when he perhaps asserted that ABS was something that may have had an impact upon the Buxton fire, the Green Wattle fire, and the outcome there. Very clearly, the ABS was not designed, and it's a part of his evidence that I heard today, was not designed to meet that particular risk. It's about
the risk being
the falling object. That's exactly
down
right.
a straight public road.
Yeah, indeed. Appreciating that our appliances are meant for off-road driving, meant for fire access, fire trail environments, which are often presented with four-wheel driving conditions. I think the ABS may have some complicating factors about the way the appliance is operated if we didn't truly understand what it does. Our appliances have anti-brake skid as a part of the off the production line safety profile, but as we engage into in forward driving operations, we actually have a design mechanism within the appliance which disables that particular element of what is a safety mechanism that I think is principally designed for on-road highway type driving.
Are you able to answer this question, Deputy Commissioner? If an AEBS, Advanced Emergency Braking System, was installed, is that something that can be disabled as well? Similar to the...
Look, I will in a really uninformed way say I would imagine so, but I can't speak comprehensively to that, I'm afraid.
Her Honour also heard some evidence from the experts today in relation to there being no Australian standard or Australian design rule that really deals with the problem that confronts your organisation in relation to occupant protection and safety. There is the organisation that they referred to of AFAC.
Yes.
That's the Australasian Fire and Emergency Service Authorities Committee?
Council, yes.
Council. And the RFS is a member of
indeed
that council. What is its remit? What does it do?
AFAC, Your Honour, is effectively the industry representative body. It is the coalition of several dozen firefighting agencies and emergency services that includes the SES through to the land managers, Forestry Corporation, etc., who have an interest in firefighting and emergency services. AFAC is, from a council perspective, is chaired by Commissioner York from the New South Wales SES and has my commissioner and his representatives and counterparts from right across the country as the principals within that particular council. What they do, though, is that they act as an advocacy point for the interests of each of the agencies, the functions that we perform, and they seek to understand principally what is innovative in the firefighting and emergency services sector. They drive a lot of the doctrine and the standards that applies right across our sector, from how incident management teams ought to be operated and what the construct of them is, right through to the design and technical groups that will look to best practice in firefighting appliance design through to personal protective clothing.
And that organisation, from your perspective at least, would that be a good vehicle, and pardon the pun, but would it be an appropriate vehicle for a committee to look at a design standard?
I have no doubt that it would be absolutely appropriate for that purpose.
And is that because it's got the expertise, industry expertise or first responder expertise, but it has the resources necessary to pull in other experts if need be?
Yeah, I think that's right. It certainly has a very important interest group as its core. At its core, it also has an ability to advocate for and be a body that seeks to influence government outcomes. So it can be our industry representative body, but importantly, it's the place where the experts coalesce in terms of firefighting and what is new in the world of firefighting and what we can do to make sure that as a combat agency, we are at the cutting edge of technology doctrine and innovation in terms of, as I said, things like fire appliance design.
And those other states within Australia, are they using similar appliances, Cat 1s, Cat 6, 7s, 13s, whatever it may be, to New South Wales, or are they slightly different in terms of their configuration?
Look, there is a similarity, but it's a loose similarity across the nation in terms of how each jurisdiction categorises their appliances. But in broad terms, each will have an appliance that is principally targeted at forest firefighting or grassland firefighting or urban firefighting. So in broad terms, we are all doing loosely the same in terms of what it is that are the designs and capability requirements of our appliances.
I take it then it's not inconceivable, picking up some of the evidence from the experts, that if there was an Australian standard designed and approved, that organisation could potentially have purchasing power to go to a manufacturer to manufacture a particular category of fire appliance that could be utilised across the nation.
Look, I don't know that AFAC would be the point at which we would negotiate a commercial outcome. I think that that's still going to be very much down to each of the jurisdictions. Where the benefit would be derived is that we have a singular design or a catalogue of capability designs that would be able to be used by the jurisdictions to then go and negotiate commercially. Where there is some difficulty in terms of a national purchasing environment is that each of the jurisdictions themselves, where New South Wales, those in Victoria, have unique procurement rules that bind us to the state obligations that we've got. But that said, each of the firefighting agencies and emergency service providers in the state of New South Wales do leverage off common contract provisions that come from a standard AFAC design contract. So Fire Rescue New South Wales, RFS, SES, we combine regularly to increase our purchasing power.
And just finally, if I may, Deputy Commissioner, would it be fair to say that Her Honour can be filled with some confidence that the New South Wales Rural Fire Service is working towards implementing a holistic solution to ensure occupant safety is paramount?
That is, yes, you can, Your Honour. That is the thing that we are here to do, is to make sure that our firefighters are safe.
Yes, thank you.
That concludes the examination, Your Honour.
Thank you, Mr. Castlett. Mr. Friend?
No questions, thank you, Your Honour.
Thanks very much, Deputy Commissioner.
Thank you.
Your Honour, that concludes the evidence in relation to that particular case study which related to vehicle design and safety. Next week, fire prediction and modelling was scheduled to commence on Monday. It may be that it'll need to commence on Tuesday and run possibly to Wednesday, followed by some closing addresses and perhaps some argument in relation to one particular matter. I say that for this reason, is that recent material was served by the New South Wales RFS, and I say that without any criticism. Dr Marsden Smedley, the relevant expert engaged by those assisting Your Honour, has dealt with some aspects of that material but may not be able to deal with all of it until Friday of this week, which means that there may be a further report served late. And it's for that reason that I'd seek Your Honour's indulgence to perhaps start that case study on the Tuesday to give my learned friend and his client sufficient time to deal with the late service of that potentially additional material.
Thank you, Your Honour. We're content with that, and I've discussed it with my learned friend. I think the only qualification is if the material which is served on Friday causes insuperable difficulty, we'll need to raise that, but we'll do that immediately. Otherwise, we're content to start on Tuesday.
All right, we'll adjourn today and resume 10 a.m. on Tuesday.
Please, voice.